to make a machine learning model more robust to outliers. It's a problem that many data scientists struggle with, so let's break it down. Firstly, what are outliers? They're data points that don't fit the general pattern of the data, and they can be extremely harmful to machine learning models in their training stage. Let me explain why. Squared error is a loss function in machine learning, and we find it by taking the gap between the model's predicted value and the true value and then squaring that number. You can probably imagine that when we're squaring a value this big, mistakes blow up fast, so those few extreme outliers can absolutely dominate the model's training. The extra pull drags the model's fitted line or boundary towards the outliers and, in turn, worsens the model's performance in the test phase. So, to avoid this from happening, you're going to follow the next 3 steps. The first one is to make your pre-processing robust. Robust scaling means preparing your numeric features in a way that prevents those few outliers from gaining control of the model. In this process, to center a feature, you're going to shift every value by the median so that the middle becomes 0. To size a feature, you're going to scale every data point by the interquartile range, the spread of the middle 50%, so most values also land near 0. For example, let's say we're looking at a data point of 70. If the median is 50 and the interquartile range is 20, that value ends up only about 1 unit above the center after scaling. Some data scientists use the mean to center and standard deviation to scale, which is generally helpful if you have a roughly bell-shaped curve and a few outliers. However, when we have highly varied data, we want to stick to the median and interquartile range. The next step is to make your loss function robust. Maybe you've heard of Huber loss before, which is another way to score errors during training. In Huber loss, small mistakes, which are when the model's prediction only varies slightly from the true value, are handled with squared error, which we talked about before, so that the model learns precisely from the bulk of the data. Very large mistakes are softened and handled with absolute error so that a few outliers do not take over the learning process. In practice, this keeps your line and boundary close to the real data, which is what we want. The third step is to use a robust estimator. An estimator is the model itself or a rule that turns predictions into inputs, for example, a linear regression line or a decision tree. A robust estimator tries to learn the main pattern without being pushed around by a few radical points. Ransack is an example of a robust estimator that works by repeatedly picking a tiny random sample of the data, fitting a model, and checking which points agree with it. The points that agree are called inliers, and the ones that clearly do not are called outliers. Ransack keeps the fit that has the biggest set of inliers and then refines the model on only those points. This helps especially when some data is simply wrong, like a broken sensor reading, so those errors and outliers do not drag the line or boundary off course. I would recommend using your usual model first, and then if you're still noticing a tilted fit and you've done the prior steps, then switch to Ransack. With these 3 steps, you can build machine learning models that are resilient to outliers. Don't forget to save this video for the next time you're working with crazy data and follow for more.